Model 9, building a complex mobile app and UI UX design. In this model, which is Model 9 of the mobile app development course, where we evaluate our focus to the architectural and engineering requirements necessary for large-scale enterprise-grade applications. What you will learn: defining the core drives of mobile app complexity, mastering clean architecture and the dependencies rule, utilizing microservices and the back end for front end or BFF pattern, implementing scalable, robust state management, designing consistent UI/UX system, engineering for high performance and real-time features. Introduction. Complexity is managed through good design. What makes an app complex? Complex mobile apps are characterized by multiple integrated features, multiple users, roles, real-time data requirement, sophisticated back-end interaction, high scalability demands, and intricate user experiences that must remain initiative despite their depth. This module addresses the challenges and techniques involved in designing and building complex mobile applications, covering advanced architectural patterns, state management at scales, performance engineering, advanced UI/UX principles, and real-time features. These are the skills that distinguish senior mobile engineers from junior ones. Core truths: complexity is never eliminated, it is managed through good architectural design. What makes a mobile app complex? 5 dimensions of a mobile app complexity. Number 1, feature breadth. Super apps combining, which has to do with super app combining mobile money, social delivery, and ride hailing in one product. Then number 2, that is user role complexity. This has to do with distinct workflows, permission levels, UI interface for each different user type. Number 3, data complexity. Large structured and unstructured data volume with real-time synchronization requirements. Performance requirements, that is number 4. In this case, near instant responses under high load with graceful, non-blocking offline handling. Integration complexity, multiple payment gateways, mapping APIs, analytics platforms, and author provides combines. Clean architecture, the dependency rule. Source code dependencies can only point inwards. Framework and drivers. Interface, adapters, layer 3. Use case, application, layer 2. Entities, domain, innermost core. So for framework and drivers, that is the outermost layer. In this case, React Native, Flutter, Android SDK, iOS SDK, database, UI frameworks, web frameworks, the implementation details, the parts that change most frequently. Interface adapters layers. In this case, controllers, presenters, view models, gateways, and repositories. Convert data between the format most convenient for use case and external agencies. Then in the case of use case, application layer 2. Application-specific business rules orchestrate the flow of data to and from entities, encapsulate all the cases of the system, independent of UI. It is independent of UI. Entities, that is the domain, innermost core. Core business object and rules, enterprise-wide policies, completely independent of any framework, database of UI, least likely to change over time. Microservices, BFF, pattern and event-driven architecture. Advanced back-end patterns for complex mobile app. We have microservices, BFF pattern, back-end for front ends, then event-driven architecture. For micro web services, it include separate back-end into independent domain services, user services, product services, order services, notification services. Then next, we have each service has its own isolated database and also independent deployment, no big bang release needed. Moreover, teams can work in parallel or different services. Lastly, it is best for large teams building at high velocity. Then for BFF pattern, back end for front ends. Aggregation layer tailored to each client type. Mobile BFF return exactly what mobile needs in one call. Reduces 8 separate API calls to one aggregated response. Highs back-end microservices complexity from mobile clients. Different BFFs for iOS, Android, and web if needed. Best for complex multi-services back-end architectures. Event-driven architecture. Components communicate via events, not direct calls. Message brokers, Kafka, AWS, SQS/SNS, Google Pub/Sub. Publishers emit events. Subscribers consume them asynchronously. Loose coupling. Services are independent of each other. Enables eventually consistency at very large scale. And last, it is best for high traffic, real-time, and resilient system. State management skills. State management skills is the heart of complex UI. As your application grows, passing props down through multiple layers become unmanageable. We adopt predictable state management patterns such as Redux, block, Riverpod to ensure that state remain a single source of truth. This facilitates time travel debugging, easier testing, and consistent user interface, even when data is being updated simultaneously from background services and user interaction. So we have global state, drive state, asynchronization state, and optimistic UI. For global state, authentication status, it includes authentication status, cards, team, notification, which shared across dozens of unrelated screens. And for drive state, computed from multiple sources and must stay in synchronization automatically without manual update. Asynchronized states, every API call has loading, from loading to success, from success to error, from error to empty. Life cycle that must be handled gracefully. Optimistic UI shows changes instantly before server confirms, then roll back automatically if the server rejects. Advanced state management solution by platforms. We have Flutter, Android, Kotlin. We have React Native. We have iOS Swift UI. For Flutter, block stream plus event, separate UI from logic, Riverpod, compile, save, testable dependency injunction. Android Kotlin, view model plus state flow and the unidirectional data flow, UDF. Google's official recommended architecture pattern. Reactive Native, Redux Chocolate, predictable state, excellent dev tools. Then iOS Swift, the composable architecture, TCA, by point pre-combine plus at state object and observable object wrappers. Advanced UI design system and navigations. Complex applications require consistency to remain usable. We achieve this through design system. A well-constructed design system defines your typography, color, plates, spacing, and component libraries as reusable code artifacts. This ensures that every developer on the team uses the exact same interface element, significantly reducing the cognitive load on the user and minimizing technical debt within your code base. Micro interaction, making apps feel alive, execute in under 300 milliseconds, must have a clear single purpose, example like animations, haptic feedback, pull to refresh, completion ticks. Performance engineering, building fast responsive app at scales. That is, we have rendering performance, memory management, and network automation. We address performance. Finally, we address performance. Complex apps often require real-time data using protocols like WebStock, gRPC, Firebase real-time database. Performance engineering is inactive. Continuous process. We must optimize image loading, implement aggressive caching, minimize main thread work, and profile the app constantly to identify bottleneck. Remember, in complex system, latency is your enemy. So for rendering performance, fine-grained reactivity, avoid rebuilding the entire widget tree for small changes. Constructors plotter or react.memo to prevent unnecessary re-renders. Reference boundary plotter to isolate expensive render operation. Lazy loading for large lists. Only render what is visible on screen. Profile with DevTools before and after every optimization change. For memory management, release resources, controllers, and stream. When screens are deposed, image caching with configurable size limit, evict all items, lazy loading for lists, never instantiate off-screen widget eagerly, avoid return cycle and strong referencing loops in closure. Profile memory with Android Studio memory, profiler or instrument. Network optimization, request batching, response caching at the client level with TTL, and also background preparation of content the user will likely need next. GraphQL to request exactly the field needed. Exponential backup retrieval logic for failed network request. Real-time features, technology and use case. 4 approaches to real-time data in mobile app. We have WebSockets, server-sent events, we have Firebase real-time, we have GraphQL subscription. WebSockets, chat apps, collaborative editing, live support scores, trading dashboard. Persistent bi-directional connection between client and server. Both can send message at any time. Best for high frequency two-way data exchange. Require connection management. Server sent events. That is the second one. It is the unidirectional streaming from server to client. Uses standard HTTP. It is simpler to implement than WebSocket. Auto reconnect on disconnect. It is best for one-way live data stream. Firebase real-time authentication. It is automatic real-time synchronization built into SDK. It handles reconnection and offline synchronization automatically. Simplest implementation fast for most mobile real-time user cases. GraphQL subscription. GraphQL, it queries that stay often and push update when data changes, transmitted over WebSocket, type safe. Client receive exactly the data shape they declare in the subscription. Do's and don'ts in complex app development. Do, make sure, apply clean architecture from day one. Use the BFF pattern to reduce number of API calls your mobile and client must make. Choose the right management solution for your platform and team skills. Build a design system before building individual screen. Consistent at scale requires profile performance before and every optimization. Major don't guess, use WebSocket for bidirectional real-time SSE for server to client stream. Don't violate the dependency rule. Never import from out layers into inner domain layers. Don't put business logic in view models, presenters, or UI component. Don't manage state with state at scales. Don't build real-time features with fooling. It drains battery and server's resources. Don't ignore performance until users complain. Profile every release. Don't build one-gate monolithic app. Break complex features into independent modules. Key takeaways. To summarize this model, complexity is managed through good design, not avoided through simplification. By adapting clean architecture, leveraging BFF patterns, standardized with design system, and obsessively engineering for performance, you build the foundation required for applications that serve millions of users with reliability and elegance. You must remember all this. Model 9 assessments. Part your final your assessment for this model consists of two parts. Part A 20-part knowledge quiz covering the core architectural concept of the model. An 80-point written reflection. You are tasked with proposing the technical architecture for high-scale services such as ride-hailing or food delivery app. You must detail your choosing architectural pattern, your state management strategy, how you will handle real-time features, and your approach to performance engineering. Please refer to the assessment rubric for the detailed grading. Conclusion: building complex mobile app is the most demanding and rewarding challenge in mobile development. Complexity is never eliminated. It is managed through good design choices in architecture, data structure, user interfaces, and team process. Developers who invest in understanding clean architecture, advanced state management, event-driven system, real-time technologies, and performance engineering at scale will be equipped to build the next generation of mobile product, the one that serves millions of users with reliability, speed, and elegance. Key takeaway: complexity is managed through good design, not avoided through simplification. Thank you for listening.